Hey guys, I'm just making a quick video on trig and an introduction to the trig ratios. Alright, let's have a look. Trigon, another word for triangle. As you would probably remember from class, a gon, or gon means sides, polygon means many sides, tri means three, so three-sided shape is a triangle. Trigonometry is just the study or the measurement of triangles. Trig uses the unit circle. What this means is that if we turn this to a very rough circle, hang on, what we have are side lengths of 1. Alright, so any of these radii or radius is going to be 1. Alright, with trig ratios we can find missing side lengths when we have one side length and at least one internal angle. Let's get rid of these again. Okay, so for example, if I had this angle, let's call it 30 degrees, and say I had the hypotenuse, maybe it was 20 meters, I can work out either of these two sides quite easily. Remember, with Pythagoras, we can work out a missing side length when we're given two side lengths. But with trig, we can use internal angles to work out missing side lengths. So it's really handy. Alright, to do this, i.e. to calculate the missing side length, we need to understand trig ratios, sine, cos and tan. This little symbol here is theta, and it's just the universal symbol for angle size. So sine theta, cos theta and tan theta. Alright, a little thing to help you remember this is some old hags can't always hide their old age. Yay! Easy one to remember. Obviously the S refers to the sine, opposite side over hypotenuse, cosine or cos, adjacent side over the hypotenuse, and for tan or tangent, opposite side over adjacent sides. What do these sides mean? Let's have a look at the next slide. Alright, now if I've got my angle, 30 degrees in this case, I've got this side length, which of course is the hypotenuse, and I've got this side length, let's call it x. We don't have this one, doesn't matter, we don't need it. From this angle, pretend you're looking in this direction, the opposite angle, the opposite side is x. This is hypotenuse. If I've got opposite side and hypotenuse, I'm thinking straight away sine theta. Alright, why is that? Because sine equals opposite side over the hypotenuse. So to calculate this, I'll just bring this down a bit, and I'm going to have to open up my calculator as well. Hang on. Alright, got my calculator ready. Okay, sine, let's work this out. Sine 30 degrees equals opposite, which is x, over the hypotenuse, which is 15. Okay, sine 30, when I punch that in, equals 0.5. So 0.5 equals x over 15. Now, of course, to isolate the x, I'm going to have to do something to the 15. The opposite of dividing is to multiply. Multiply both sides by 15. So 15 times 0.5 equals x. So x equals, that's a terrible x, I'm going to do that again. No, it's not going to erase. X equals 7.5. Alright, so I found out the missing side length, x. Alright, of course, once I've got those two side lengths, it's just a matter of using Pythagoras' theorem to work out the third side length if I need to, or using another trig function. Okay, missing side length. Let's do this one again. Alright, in this case, I've got 50 degrees as my given angle. However, I've got my adjacent side. This is the side adjacent to the angle, and the hypotenuse. So to do this, I'm thinking which trig function adjacent over hypotenuse is cosine. So cosine theta equals adjacent side over hypotenuse. So in this case, I've got cosine 50 degrees equals x over 30. Now instead of doing the working at cos 50 first, I'm just going to bring the 30 down. So 30 cos 50 degrees equals x. Cos 50 equals 0.64. So 30 times 0.64 equals x. So therefore, x equals 30 times 0.64 equals 19.2. Lovely. Very easy. Let's do another one. Alright, and I think you've guessed what I'm going to do for this one. That's right. It's going to be tan theta. Why is that? Because I'm not given the hypotenuse in this case, but I'm given the adjacent side and the opposite. Some old hags can't always hide their old age, opposite over hypotenuse. So in this case, tan 45 degrees equals A over 20. So A equals 20 tan 45 degrees, which will equal, now tan 45 is 1. So it's 20 times 1, which of course equals 20. Alright, interesting. Side lengths of 20. What would the hypotenuse be? You could work that out using Pythagoras' theorem, which is c squared equals a squared plus b squared. 20 squared is 400. 400 plus 400 is 800. Square root of that equals 28.28 or 28.3. So I could work out that side length. Anyway, that's enough for today. Thanks for listening and see you soon.